Так, еще раз здравствуйте. У нас по расписанию осталась еще одна пара. Так, меня слышно?
Да, вас слышно.
Да, все.
Хорошо. Ну, поскольку и вы уже устали, и я тоже немножко, честно говоря. Вот. Поэтому сейчас мы опять будем смотреть вот этот, значит, вебинар компании NVIDIA. Ну и там я буду по ходу давать какие-то комментарии. Вообще очень интересное мероприятие, тем более выложили его русский перевод, поэтому стоит посмотреть. Так, экран виден, да?
Да, виден.
Хорошо, включаем тогда трансляцию. Так, звук есть, да?
Есть.
Хорошо, замечательно. Тогда включаю на полный экран.
I am a creator. Blending art and technology. To immerse our senses. I am a healer, helping us take the next step and see what's possible.
Ну вот тут показывают, что при помощи искусственного интеллекта уже даже некоторым людям значит, возвращают частично возможность значит, видеть вот, полностью слепым от рождения.
I am a guardian, defending our oceans. And the magnificent creatures that call them home. I am a protector, helping the earth breathe easier. And watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
There are powerful forces shaping the world's industries. Accelerated computing that we pioneered has supercharged scientific discovery while providing the computer industry a path forward. Artificial intelligence particularly has seen incredible advances. With NVIDIA GPUs, computers learn, and software writes software no human can. The AI software is delivered as a service from the cloud, performing automation at the speed of light. Software is now composed of microservices that scale across the entire data center, treating the data center as a single unit of computing. AI and 5G are the ingredients to kickstart the fourth industrial revolution, where automation and robotics can be deployed to far edges of the world. There is one more miracle we need: the metaverse, a virtual world that is a digital twin of ours. Welcome to GTC 2021. We're going to talk about these dynamics and more. Let me give you the architecture of my talk. It's organized in 4 stacks. This is how we work. As a full stack computing platform company, the flow also reflects the waves of AI and how we're expanding the reach of our platform to solve new problems and to enter new markets. First is Omniverse, built from the ground up on NVIDIA's body of work. It is a platform to create and simulate virtual worlds. We'll feature many applications of Omniverse, like design collaboration, simulation, and future robotic factories. The second stack is DGX and high-performance data centers. I'll feature Bluefield, new DGXs, new chips, and the new work we're doing in AI, drug discovery, and quantum computing. Here I'll also talk about ARM and new ARM partnerships. The third stack is one of our most important new platforms, NVIDIA EGX with Aerial 5G. Now enterprises and industries can do AI and deploy AI on 5G. We'll talk about NVIDIA AI and pre-trained models like Jarvis Conversational AI. And finally, our work with the auto industry to revolutionize the future of transportation, NVIDIA Drive. We'll talk about new chips, new platforms and software, and lots of new customers. Let's get started. Scientists, researchers, developers, and creators are using NVIDIA to do amazing things. Your work gets global reach with the install base of over 1 billion CUDA GPUs shipped and 250 exaflops of GPU computing power in the cloud. 2.5 million developers and 7,500 startups are creating thousands of applications for accelerated computing. We're thrilled by the growth of the ecosystem we're building together, and we'll continue to put our heart and soul into advancing it. Building tools for the Da Vinci's of our time is our purpose, and in doing so, we also help create the future. Democratizing high-performance computers is one of NVIDIA's greatest contributions to science. With just the GeForce, every student can have a supercomputer. This is how Alex Krzyzewski, Ilya, and Hinton trained AlexNet that caught the world's attention on deep learning. And with GPUs in supercomputers, we gave scientists a time machine. A scientist once told me that because of NVIDIA's work, he could do his life's work in his lifetime. I can't think of a greater purpose. Let me highlight a few achievements from last year. NVIDIA is continually optimizing the full stack. With the chips you have, your software runs faster every year, and even faster if you upgrade. On our golden suite of important science codes, we increased performance 13-fold in the last 5 years. And for some, performance doubled every year. NAMD Molecular Dynamics Simulator, for example, was re-architected and can now run across multiple GPUs. Researchers led by Dr. Rami Amaro at UC San Diego uses multi-GPU NAMD running on Oak Ridge Summit supercomputers 20,000 NVIDIA GPUs to do the largest atomic simulation ever, 305 million atoms. This work was critical to a better understanding of the COVID-19 virus and accelerated the making of the vaccine. Dr. Amaro and her collaborators won the Gordon Bell Award for this important work. I'm very proud to welcome Dr. Amaro and more than 100,000 of you to this year's GTC, our largest ever by double. We have some of the greatest computer scientists and researchers of our time speaking here. 3 Turing Award winners, 12 Gordon Bell Award winners, 9 Kaggle Grand Masters, and even 10 Oscar winners. We're also delighted to have the brightest minds from industry sharing their discoveries. Leaders from every field: healthcare, auto, finance, retail, energy, internet services, every major enterprise IT company. They're bringing you their latest work in COVID research, data science, cybersecurity, new approaches to computer graphics, and the most recent advances in AI and robotics. In total, 1,600 talks about the most important technologies of our time, from the leaders in the field that are shaping our world. Welcome to GTC. Let's start where NVIDIA started, computer graphics. Computer graphics is the driving force of our technology. Hundreds of millions of gamers and creators each year seek out the best NVIDIA has to offer. At its core, computer graphics is about simulations, using mathematics and computer science to simulate the interactions of light and material, the physics of objects, particles, and waves, and now simulating intelligence and animation. The science, engineering, and artistry that we dedicate in pursuit of achieving Mother Nature's physics has led to incredible advances and allowed our technology to contribute to advancing the basic sciences, the arts, and the industries. This last year, we introduced the second generation of RTX, a new rendering approach that fuses rasterization and programmable shading with hardware-accelerated ray tracing and artificial intelligence. This is the culmination of 10 years of research. RTX has reset computer graphics, giving developers a powerful new tool just as rasterization plateaus. Let me show you some amazing footage from games in development. The technology and artistry is amazing. We're giving the world's billion gamers an incredible reason to upgrade. RTX is a reset of computer graphics. It has enabled us to build Omniverse, a platform for connecting 3D worlds into a shared virtual world. One's not unlike the science fiction metaverse first described by Neil Stephenson in his early 1990s novel Snow Crash, where the metaverse would be collectives of shared 3D spaces and virtually enhanced physical spaces that are extensions of the internet. Pieces of the early metaverse vision are already here. Massive online social games like Fortnite or user-created virtual worlds like Minecraft. Let me tell you about Omniverse from the perspective of two applications, design collaboration and digital twins. There are several major parts of the platform. First, the Omniverse Nucleus, a database engine that connects users and enables the interchange of 3D assets and scene descriptions. Once connected, designers doing modeling, layout, shading, animation, lighting, special effects, or rendering can collaborate to create a scene. The Omniverse Nucleus is described with the open standard USD, Universal Scene Description, a fabulous interchange framework invented by Pixar. Multiple users can connect to Nucleus, transmitting and receiving changes to the world as USD snippets. The second part of Omniverse is the composition, rendering, and animation engine, the simulation of the virtual world. Omniverse is a platform built from the ground up to be physically based. It is fully path traced. Physics is simulated with NVIDIA PhysX, materials are simulated with NVIDIA MDL, and Omniverse is fully integrated with NVIDIA AI. Omniverse is cloud native, multi-GPU scalable, and runs on any RTX platform and streams remotely to any device. The third part is NVIDIA Cloud XR, a Stargate, if you will. You can teleport into Omniverse with VR, and AIs can teleport out of Omniverse with AR. Omniverse was released open beta in December. Let me show you what talented creators are doing. Creators are doing amazing things with Omniverse. At Foster and Partners, designers in 17 locations around the world are designing buildings together in their Omniverse shared virtual space. ILM is testing Omniverse to bring together internal and external tool pipelines for multiple studios. Omniverse lets them collaborate, render final shots in real time, and create massive virtual sets like holodecks. Ericsson is using Omniverse to do real-time 5G wave propagation simulation with many multi-path interferences. Twin Earth is creating a digital twin of Earth that will run on 20,000 NVIDIA GPUs. And Activision is using Omniverse to organize their more than 100,000 3D assets into a shared and searchable world. Bentley is the world's leading infrastructure engineering software company. Everything that's constructed, roads and bridges, rail and transit systems, airports and seaports, about 3% of the world's GDP, or $3.5 trillion a year. Bentley software is used to design, model, and simulate the largest infrastructure projects in the world. 90% of the world's top 250 engineering firms use Bentley. They have a new platform called iTwin, an exciting strategy to use the 3D model after construction to monitor and optimize the performance throughout its life. We're super excited to partner with Bentley to create infrastructure digital twins in Omniverse. Bentley is the first third-party company to be developing a suite of applications on the Omniverse platform. This is just an awesome use of Omniverse, a great example of digital twins, and Bentley is the perfect partner. And here's Perry Nightingale from WPP, the largest ad agency in the world, to tell you what they're doing.
WPP is the largest marketing services organization on the planet, and because of that, we're also one of the largest production companies in the world. That is a major carbon hotspot for us. We've partnered with NVIDIA to capture locations virtually and bring them to life in studios with Omniverse. Over 10 billion points are turned into a giant mesh in Omniverse. For the first time, we can shoot locations virtually that are as real as the actual places themselves. Omniverse also changes the way we make work. A collaborative platform that means multiple artists at multiple points in the pipeline in multiple parts of the world can collaborate on a single scene. Real-time CGI and sustainable studios, collaboration with Omniverse is the future of film at WPP.
One of the most important features of Omniverse is that it obeys the laws of physics. Omniverse can simulate particles, fluids, materials, springs, and cables. This is a fundamental capability for robotics. Once trained, the AI and software can be downloaded from Omniverse. In this video, you'll see Omniverse's physics simulation with rigid and soft bodies, fluids, and finite element modeling, and a lot more. Enjoy. Omniverse is a physically based virtual world where robots can learn to be robots. They'll come in all sizes and shapes: box movers, pick and place arms, forklifts, cars, trucks. In the future, a factory will be a robot, orchestrating many robots inside, building cars that are robots themselves. We can use Omniverse to create virtual factory, train and simulate the factory and its robotic workers inside. The AI and software that run the virtual factory are exactly the same as what will run the actual one. The virtual and physical factories and their robots will operate in a loop. They are digital twins, connecting to ERP systems, simulating the throughput of the factory, simulating new plant layouts, and becoming the dashboard of the operator, even uplinking into a robot to teleoperate it. BMW may very well be the world's largest custom manufacturing company. BMW produces over 2 million cars a year. In their most advanced factory, a car a minute. Every car is different. We're working with BMW to create a future factory, designed completely in digital, simulated from beginning to end in Omniverse, creating a digital twin and operating a factory where robots and humans work together. Let's take a look at the BMW factory.
Welcome to BMW Production Benson. I'm pleased to show you why BMW sets the standards for innovation and flexibility. Our collaboration with NVIDIA Omniverse and NVIDIA AI leads into a new era of digitalization of automobile production.
Fantastic to be with you, Milan. I'm excited to do this virtual factory visit with you.
We are inside the digital twin of BMW's assembly system, powered by Omniverse. For the first time, we are able to have our entire factory in simulation. Global teams can collaborate using different software packages like Revit, CATIA, or point clouds to design and plan the factory in real-time 3D. The capability to operate in a perfect simulation revolutionizes BMW's planning processes.
Are those gaskets still in the right place for you?
Yeah, BMW regularly reconfigures its factories to accommodate new vehicle launches. Here we see two planning experts located in different parts of the world, testing a new line design in Omniverse. One of them wormholes into an assembly simulation with a motion capture suit, records task movements, while the other expert adjusts the line design in real time. They work together to optimize the line as well as worker ergonomics and safety.
Can you tell how far I have to bend down there? So we'll get you a taller one, but it's perfect.
We would like to be able to do this at scale in simulation.
That's exactly why NVIDIA has digital human for simulation. Digital humans are trained with data from real associates. You could then use digital humans as simulation to test new workflows for worker ergonomics and efficiency. Now your factories employ 57,000 people that share workspace with many robots designed to make their jobs easier. Let's talk about them.
You're right, Jensen. Robots are crucial for a modern production system. With NVIDIA Isaac Robotics platform, BMW is deploying a fleet of intelligent robots for logistics to improve the material flow in our production. This agility is necessary since we produce 2.5 million vehicles per year. 99% of them are custom.
Synthetic data generation and domain randomization available in Isaac are key to bootstrapping machine learning. IsaacSim generates millions of synthetic images and vary the environment to teach the robots. Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. It is ideal for generating ground truth, whether for detection, segmentation, or depth perception. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory for mission control. They can monitor in real time complex manufacturing cells, update software over the air, launch robot missions, and teleoperate. When a robot needs a helping hand, an alert can be sent to mission control, and one of your associates can take control to help the robot. We're in the digital twin of one of your factories. but you have 30 others spread across 15 countries. The scale of BMW production is impressive, Milan.
Indeed, Jensen, the scale and complexity of our production network requires BMW to constantly innovate. I'm happy about the tight collaboration between our two companies. NVIDIA Omniverse and NVIDIA AI give us the chance to simulate all 31 factories in our production network. These new innovations will reduce the planning times, improve flexibility and precision, and at the end, produce 30% more efficient planning processes.
Milan, I could not be more proud of the innovations that our collaboration is bringing to the factories of the future. I appreciate you hosting me for a virtual visit of the digital twin of your BMW production. It is a work of art. The ecosystem is really excited about Omniverse. This open platform with USD Universal 3D Interchange connects them into a large network of users. We have 12 connectors to major design tools already, with another 40 in flight. Omniverse connector SDK is available for download now. You can see that the most important design tools are already signed up. Our Lighthouse partners are from some of the world's largest industries: media and entertainment, gaming, architecture, engineering, construction, manufacturing, telecommunications, infrastructure, and automotive. Computer makers worldwide are building NVIDIA certified workstations, notebooks, and servers optimized for Omniverse. And starting this summer, Omniverse will be available for enterprise license. Omniverse, NVIDIA's platform for creating and simulating shared virtual worlds. Data center is the new unit of computing. Cloud computing and AI are driving fundamental changes in the architecture of data centers. Traditionally, enterprise data centers ran monolithic software packages. Virtualization started a trend towards software-defined data centers, allowing applications to move about and letting IT manage from a single pane of glass. With virtualization, the compute, networking, storage, and security functions are emulated in software running on the CPU. Though easier to manage, the added CPU load reduced the data center's capacity to run applications, which is its primary purpose. This illustration shows the added CPU load in the gold-colored part of the stack. Cloud computing re-architected the data centers again, now to provision services for billions of consumers. Monolithic applications were disaggregated into smaller microservices that can take advantage of any idle resource. Equally important, multiple engineering teams can work concurrently using CI/CD methods. Data center networks became swamped by east-west traffic generated by disaggregated microservices. CSPs tackled this with Mellanox's high-speed, low-latency networking. Then deep learning emerged. Magical internet services were rolled out, attracting more customers and better engagement than ever. Deep learning is compute intensive, which drove adoption of GPUs. Nearly overnight, consumer AI services became the biggest users of GPU supercomputing technologies. Now, adding zero trust security initiatives makes infrastructure software processing one of the largest workloads in the data center. The answer is a new type of chip for data center infrastructure processing, like NVIDIA's Bluefield DPU. Let me illustrate this with our own cloud gaming service, GeForce Now, as an example. GeForce Now is NVIDIA's GeForce in the cloud.
Так, ну, собственно, этот кусок мы уже видели, но осталось у нас 9 с небольшим минут. Вот. Оставить это или включить следующий фрагмент? Или это досмотрим за оставшееся время?
Да, если мы это уже смотрели, может быть, что-то другое.
Так, не подключается.
AI, computers automating intelligence, is the most powerful technology force of our time. We see AI in 4 waves. The first wave was to reinvent computing for this new way of doing software. We're all in and have been driving this for nearly 10 years. The first adopters of AI were the internet companies. They have excellent computer scientists, large computing infrastructure, and ability to collect a lot of training data. We're now at the beginning of the next wave. The next wave is enterprise and industrial edge, where AI can revolutionize the world's largest industries, from manufacturing, logistics, agriculture, healthcare, financial services, and transportation. There are many challenges to overcome, one of which is connectivity, which 5G will solve. And then autonomous systems. Self-driving cars are an excellent example, but everything that moves will eventually be autonomous. The industrial edge and autonomous systems are the most challenging, but also the largest opportunities for AI to make an impact. Trillion-dollar industries can soon apply AI to improve productivity and invent new products, services, and business models.
Вот. Перевод не очень корректный. Видимо, сделали так, загнали в распознавалку речи, потом засунули в Google переводчик и перевели. Ну вот тут, например, вот он говорит industrial edge, то есть переведено как промышленное преимущество. Вот. На самом деле это не это. Это имеется в виду edge computing, то есть значит, граничные вычисления вот, в промышленности.
We have to make AI easier to use. Turn AI from computer science to computer products. We're building the new computing platform for this fundamentally new software approach, the computer for the age of AI. AI is not just about an algorithm. Building and operating AI is a fundamental change in every aspect of software. Andrej Karpathy rightly called it software 2.0. Machine learning at the highest level is a continuous learning system that starts with data scientists developing data strategies and engineering predictive features. This data is the digital life experience of a company. Training involves inventing or adapting an AI model that learns to make the desired predictions. Simulation and validation test the AI application for accuracy, generalization, and potential bias. And finally, orchestrating a fleet of computers, whether in your data center or at the edge in the warehouse, farms, or wireless base stations. NVIDIA
Вот
created
тоже
chips,
он говорит
systems,
orchestration,
and
а
libraries
перевод
needed for
организации.
end-to-end machine learning. For example, technologies like Tensor Core GPUs, NVLink, DGX, cuDNN, Rapids, Nickel, GPU Direct, Doka, and so much more. We call the platform NVIDIA AI. NVIDIA AI libraries accelerate every step, from data processing to fleet orchestration. NVIDIA AI is integrated into all of the industry's popular tools and workflows. NVIDIA AI is in every cloud, used by the world's largest companies and by over 7,500 AI startups around the world. And NVIDIA AI runs on any system that includes NVIDIA GPUs, from PCs and laptops, to workstations, to supercomputers, in any cloud, to our $99 Jetson robot computer. One segment of computing we've not served is enterprise computing. 70% of the world's enterprise run VMware, as we do at NVIDIA. VMware was created to run many applications on one virtualized machine. AI, on the other hand, runs a single job, bare metal, on multiple GPUs and often multiple nodes. All of the NVIDIA optimizations for compute and data transfer are now plumbed through the VMware stack, so AI workloads can be distributed to multiple systems and achieve bare metal performance. The VMware stack is also offloaded and accelerated on NVIDIA Bluefield. NVIDIA AI now runs in its full glory on VMware, which means everything that has been accelerated by NVIDIA AI now runs great on VMware. AI applications can be deployed and orchestrated with Kubernetes running on VMware Tanzu. We call this platform NVIDIA EGX for Enterprise. The enterprise IT ecosystem is thrilled. Finally, the 300,000 VMware enterprise customers can easily build an AI computing infrastructure that seamlessly integrates into their existing environment. In total, over 50 servers from the world's top server makers will be certified for NVIDIA EGX Enterprise. Bluefield 2 offloads and accelerates the VMware stack and does the networking for distributed computing. Enterprise can choose big or small GPUs for heavy compute or heavy graphics workloads like Omniverse, or mix and match. All run NVIDIA AI. Enterprise companies make up the world's largest industries, and they operate at the edge. in hospitals, factories, plants, warehouses, stores, farms, city and roads, far from data centers. The missing link is 5G. Consumer 5G is great, but private 5G is revolutionary. Today, we're announcing the Aerial A100, bringing together 5G and AI into a new type of computing platform designed for the edge. Aerial A100 integrates the Ampere GPU and the Bluefield DPU into one card. This is the most advanced PCI Express card ever created. So it's not a surprise that Aerial A100 in an EGX system will be a complete 5G base station. Aerial A100 delivers up to full 20 gigabits per second and can process up to 9 100 megahertz massive MIMO for 64T, 64R, or 64 transmit and 64 receive antenna arrays. State-of-the-art capabilities. Aerial A100 is software-defined with accelerated features like PHY, virtual network functions, network acceleration, packet pacing, and line rate cryptography. Our partners, Ericsson, Fujitsu, Mavenir, Altran, and Renesas, will build their total 5G solutions on top of the Aerial library. NVIDIA EGX server with Aerial A100 is the first 5G base station that is also a cloud-native, secure AI edge data center. We have brought the power of the cloud to the 5G edge. Aerial also extends the power of 5G into the cloud. Today, we're excited to announce that Google will support NVIDIA Aerial in the GCP cloud. I have an important new platform to tell you about. The rise of microservice-based applications and hybrid cloud has exposed billions of connections in the data center to potential attack. Modern zero-trust security models assume the intruder is already inside, and all container-to-container communications should be inspected, even within a node. This is not possible today. The CPU load of monitoring every piece of traffic is simply too great. Today, we're announcing NVIDIA Morpheus, a data center security platform for real-time, all-packet inspection. Morpheus is built on NVIDIA AI, NVIDIA Bluefield, NetQ network telemetry software, and EGX. We're working to create solutions with industry leaders in data center security.
Так, ну осталось у нас меньше минуты. Я вам тогда пришлю ссылку вот на этот вебинар, и вы можете дальше посмотреть самостоятельно. Имейте в виду только, что там есть, конечно, погрешности в переводе, но это все-таки лучше, чем то, что есть там в других выкладках. Там вообще переводчики невменяемые просто там. Вот, значит, в следующий раз мы с вами тогда посмотрим, как вот при помощи вот этой вот, значит, технологии Omniverse производится проектирование